The final geometry equations we'll look at rearranging are those for the area of a circle. In our first example, we have a circle with an area of 37.5 square inches and want to find the radius. When we get to the end, we'll round our answer to 2 decimal places. If you take a look at your formula sheet, you have 2 formulas for the area of a circle. One has an R in it for radius, and one has D for diameter. Since this question's asking us to find the radius, I'll start with the equation area equals pi r squared. Substituting in what I know the area is 37.5 square inches, so that equals pi times r squared. Just like when we were rearranging the circumference equation, I can move pi from one side of the equation to the other by division. So I get 37.5 divided by pi equals r squared. You can do that step on your calculator and you should get a long decimal number, 11.9366, and the decimals go on. It's important that you don't round early, so keep that number on your calculator so you can use it again in the next step. Notice that this is the value for not r, the radius, but r squared. In order to get our variable r by itself, I again need to do the opposite operation. Remember that the opposite of squaring is square rooting. So I'll take 11.9366 and all those other decimals on my calculator, and I will square root them. You should be able to just push the square root button on your calculator and then press equals. When you do that, you get 3.4549, and the decimals go on for the radius. Now that we're at the end, we'll round that to our final answer to 2 decimal places, 3.45 inches for the radius. So again, we followed the same rules for algebra. In order to move pieces of the equation around, when we need to move a piece to the other side of the equals, we do the opposite operation. The new pairing of operations we saw here was that the opposite of squaring is square rooting. We also saw that it's important to keep all the decimal places until the end of a question. So don't round until you get to your final answer. In the next question, we have a circle with an area of 2.3 square meters and want to find the diameter. So here I'll start with the equation for area that has diameter in it. Area equals pi times the diameter squared over 4. I'll substitute in what I know. The area is 2.3 equals pi times the diameter squared over 4. If we want to do this in steps, I'll move this divide by 4 first by doing the opposite on the other side of the equation. So I get 2.3 multiplied by 4 equals pi times d squared. 2.3 times 4 simplifies to 9.2 times pi d squared. And now the steps will be the same as the question above. I'll divide each side by pi, so I get 9.2 divided by pi equals d squared. If you do that on your calculator, remember you'll get lots of decimals. For d squared, keep all of those on your calculator so that you can use your square root key on that entire decimal number in the final step. So again, to move from d squared to d, I square root on the opposite side. And rounding my final answer to 1 decimal place, we get a diameter here of 1.7 meters. Take a moment to try the next question. We have a circle with an area of 3.75 square feet. I'd like you to find the radius, and when you do this question, your radius will be in feet and you'll get a decimal answer. Go back to the previous video if you need to, but practice converting that to the number of whole feet, whole inches, and fractions of an inch to the nearest 16th of an inch. And you can check and see how you did. Solving for the radius is exactly like the first example that we did, and since our area was in square feet, our radius is in decimal feet. In this question, I asked you to then convert that to the number of feet, inches, and fractions of an inch to the nearest 16th of an inch, and those steps are shown to you here. If you need a review of that, be sure to go back to that video in the previous module. You should have got a radius at the end of 1 foot, 1 1/8 of an inch. remembering that we always reduce our fractions to lowest terms.